Hey guys, welcome back. This section is all about recursion, all about how you can solve big problems very quickly. Let's talk a bit about recursion. Simply put, recursion is just a method calling itself. For the people getting to know the recursion for the first time, recursion might appear to be obscure, difficult, and mystical, but it all settles down with practice. So, what do you do if you're having a big problem to solve? You break it into similar subproblems and use the same method to solve all the subproblems and eventually get to the solution of the original problem. Because all these subtasks help constructing the final result of the main problem by returning back the values calculated or constructed by them. So it's like a method foo, again calling method foo for solving its subproblem. Now you'll say, how is this possible? This piece of code will go into an infinite loop and will never terminate, right? If you remember the initial days when we started doing code, you will relate it to writing a while loop having a hard-coded true written as a condition that never terminates. So as the loops have conditions that decides when to terminate the loop, when we are solving a problem recursively, there is always a base condition that prevents the method calls to go into an infinite loop. So if you think about it, a base condition is a condition after which we don't have more recursive steps or calls. There most of the time you will be having a known value or a constructible value without making further recursive calls. Don't worry, let's take an example to illustrate this. The simplest example to explain this, is of calculating factorial of a number. If you want to calculate the factorial, the formula is factorial of n is equals to n multiplied factorial of n minus 1, which if expanded is same as saying factorial of n is equal to factorial of n multiplied by n minus 1 multiplied by n minus 2, and this is how decreasing the value of n until it reaches 0. So this is the formula, right? So if you create a method that calculates the factorial of n, you can use the same method to calculate the factorial of n minus 1. And you can use the same method for calculating the factorial of n minus 2 and so on until the value of n reaches 0. And the value of factorial 0 is 1. And here it should stop and should provide the solution of this step to the previous call, which in turn calculates its part and pass this on upwards, and this is how all the previous recursive calls are dependent on the space condition. Let's see this whole example using a call stack. Hope you all know about call stack. If not, call stack is a memory area where program stores the local variables, references to objects, and each method call has its own space called a stack frame or an activation record inside the stack, where it stores all of its local variables references belonging to it. Let's take a very simple example. Suppose your application is calling a method m1 which is calling a method m2 internally, and this method m2 is again calling method 3. Here each method call, as we mentioned earlier, occupies a frame in the call stack. When m1 is called, a stack frame for m1 will be there on the stack with all its local variables, references and all, and then when m1 calls m2, a stack frame for m2 is created right over m1 stack frame, and then same for m3 in the sequence. And a stack always follows last in first out order, so the first method to completely get executed is the one that got added last, the one at the top of the stack, which is m3. So it will get executed, and after its execution, m2 executes and at last m1 executes. So this is how it works. Now let's jump back to the example of finding factorial and see how its call stack will be arranged. When we will call the factorial method for the first time, let's say for 4, so here the first call would be for n equals to 4, which will perform the multiplication of 4 to factorial of n minus 1, which is factorial of 3. So this first call halts until it finds the value for factorial 3. Second call happens with n equals to 3, which again performs the multiplication of 3 to factorial of n minus 1, which in this case is factorial of 2. Again, it halts to get the value of factorial 2 so that it can calculate the value for the current call. Now the third call happens, which is 2 multiplied by factorial of 1. In this case, the value of n is 2. Again, it halts to get the value of factorial 1. And it's the last call where we have no more recursive calls. It is a base condition, so it returns 1. It is given back to the previous call where it calculates the value to be returned by this current call back to its previous call, and this way this goes on, and finally we get the value of the factorial n. So this is how recursion works. Hope you understood that in recursion we compute the result with the help of one or more recursive calls to the same function, but with inputs reduced in size or complexity, going closer towards the base case. So this was all for this lecture. In next lecture, we will talk about identifying if a problem can be solved recursively or not. So let's go there.